Hello and welcome to the CDO Magazine interview series. I am Savio Rodrigues with Trianz. Today, I have the pleasure of speaking with Brian Coogan, innovation leader at Fidelity Investments. Brian specializes in enterprise compliance, risk management, anti-money laundering, broker deal compliance, asset management compliance, operational risk management, global program management, workforce capacity modeling, and forensic testing. It's very nice to speak with you, Brian.
Well, Savio, thank you for that lengthy introduction. I guess if you stick around long enough, you get to do enough different things. But yeah, I've had a kind of a journeyed career. I never set out to do anything in the world of data or technology. That wasn't what I intended to do, but I've been really fortunate over the last, probably almost 10 years to get really heavily involved with the data side of the businesses whom I support and really just understand the power of that information and how it can materially change how we work and what we work on and what decisions that we make next. So I'm really excited to get the chance to sit down and chat with you today about what's going on in my world.
Thank you, Brian. And I know something alluded on the conversation, but I'd love our listeners to hear a little bit more about your career journey. So before joining Fidelity in June 2013, you worked as a senior manager for regulatory compliance practice at Ernst & Young. And then from 2006 to 2009, you served multiple risk and compliance roles at Merrill Lynch. Brian, you've been a data leader in the financial industry for the better part of 2 decades, as you rightly said earlier. Can you tell us a little bit more about your career experiences and influences that led to your current leadership role?
Yeah, often you don't bring people that intended to study medicine in university and go off into a career in sports medicine to a data conversation. In fact, I don't even have a degree in technology or computer science. I have a degree in business administration with a focus in marketing and advertising. And for the first kind of 5 or so years in my professional career, I worked for financial services companies doing back office operations. That was kind of like the person pulling the lever, typing the keys and entering things from pieces of paper into a keyboard, which eventually got to a database. That's as close as I got to data. And as my career evolved in various different roles, I learned more and more of the power of data. So at one point when I was at Merrill Lynch, I was in charge of pulling back all of the transactional data that we would then provide to regulators on behalf of some sort of inquiries. But it wasn't until I got to my career at Ernst & Young, where I was acting as a management consultant, that I really understood the power of data, the concept of data science. And it was in working with the anti-money laundering programs with some of our big bank customers, trying to design algorithmic programs to surveil for millions and millions of transactions in their databases to identify potential fraudulent behavior and the math that went into those calculations to derive what's an acceptable or non-acceptable activity. And that was my first real experience trying to understand how you could use data into your day job and hand over some of that computing to a machine and take it away from what humans had historically done in the past. So that's really where I got into this journey. At some point, maybe 10 years ago, someone thought I should work more on the tech side of the world, less the compliance side of the world. And I've kind of bridged both sides since. And that's really what I consider myself to be, as a bridge between my business partners and my technology partners. Though I really only speak English in the world of business, I speak business and technology. I kind of have that natural hybrid skill. So I can talk to you about the most acute large language models that you want to talk about. So when people talk about LLMs, which we'll get to at some point today, I understand fully what that means, but I also understand how to convert that back to a business problem statement and where LLMs may be appropriate in areas where they may not be, or which types of LLMs to choose from when trying to solve for a business problem. Today, if you ask me to sit down and write any string code whatsoever, I would fail the test. I don't know how to write any of it. I've never intended to. I'm really acting as a broker between a business partner and a technology partner to solve their problems. That's simply what I do, and how I got here is a strange path, but I'm here nonetheless.
I mean, you bring a unique perspective on the business and tech side for sure, Brian, and it's so apt the topic for today. Love to get more of your perspectives, certainly. especially on artificial intelligence and machine learning. We see it rapidly shaping the way we interact and transact with each other. Can you tell us a little bit more about the applications of AI in financial institutions and the potential opportunities it could bring to wealth managers and financial advisors?
I think it's going to bring a wealth of opportunities for all industries. I really do. I think it's something that's going to transcend how we work. When Fidelity brought me to their firm 10 years ago, they wanted me to build out a forensic testing program. They didn't really have a great way to internally surveil for potential bad actor scenarios at the firm. They were really looking for things like insider trading or white collar crime. The only thing that Fidelity sells is trust. Our customers trust us with their life savings, their family's endowments, their child's college savings. People give us their money to invest on their behalf and make sure it's there when they need it. And you have to have a lot of trust with your company to do that. So we want to preserve that. And if we ever have people in our house doing bad things, we want to eradicate that as quickly as possible and remediate it as fast as we can. That's what I was set out to do 10 years ago. I still support that business at an arm's length today. But what we started to do is I wanted to approach it similarly to the way a bank would do anti-money laundering. How do you surveil all of your internal transactions with customer portfolios, portfolio evaluations? A human can't compute all of that. We've got millions of customers across tens of thousands of portfolios. So we needed to invoke machinery to do those computations on our behalf. And we started to build out our first machine learning algorithms in the beginning of 2014, so about 7 or 8 years ago. And we were very successful deploying those into our systems. Things that I couldn't do as a human, this machinery could do on my behalf with some conditional statements. And it was trained off of large data sets. And that's one benefit we have at Fidelity is we've been collecting a lot of data for a long time and we've saved all of it. It's the benefits of being over 75 years old in the industry. So we've built out models to understand what are portfolio managers' trading behaviors, how do they correlate with what's happening in the broader marketplace, what are indicators of potential risk or fraud that we need to be concerned for. And that's what we started building. Since then, we've built probably hundreds iterations of different learning models. One of the things that people really need to understand is you can't just set it and forget it. These models are not static, they're organic, and they have to be, just like humans, we have to constantly relearn and reevaluate how we're doing it. And you also have to remember each model has inherently human bias in its own development. So you have to have ways to calibrate that. So what I always say to people is you'll never hit perfection. And as a data scientist, if you think you are, you're going to drive yourself crazy because it's not going to happen. But you have this kind of linear line of what you believe to be perfect. And whatever you develop is going to always just miss the mark. Sometimes you're above, sometimes you're below, but you're always oscillating back and forth between what that line of perfection is. And you're as close to perfect as possible. And that's generally what most businesses are going to strive for, because no human's going to be that good. No human can do it that quickly. So I'm really excited where we are in the marketplace today. I think the technology has evolved to a point where it can do things we've never seemed could be done in our lifetime, and it's happening right now. I mean, we've been talking to our voice activated devices in our homes for a long time now, but to see the way that these have evolved and how they're at our fingertips, it's really exciting. These are really exciting times in our business.
Oh, absolutely, Brian. And I think with with the increasing pressure to forecast risk, prevent fraud, comply with regulations, we see the AI and machine learning, offering a lot of promises in this area, and it's pretty early stages, and fastly adopting in this field. Can you tell us how Fidelity has found success? And more importantly, the challenges that I would, love to know what you have come across so far.
Yeah, and one of the biggest costs for us as a company is we pay for a lot of data, and a lot of that data is publicly available. And then there's a lot of data that, since it is publicly available, we pay a lot of human capital to go out and grab the data, bring in the data, take it from a prospectus, take it from a 10K filing, an annual report. A lot of it's tabular, some of it's textual, and it all is in context. And to date, there really hasn't been many machines that could look at, say, an annual report that's written in German, that's 500 pages long, and it follows European accounting practices, and you just lift and shift and bring all that data in. There's no scraping mechanism to do that right now. There's not very many. And that's the data that you pay for. You pay companies like Bloomberg or FactSet for that information. There's opportunities for us, and these are some things that we've worked on. How could you digitize those documents? How could you take these unstructured documents? Sometimes they're not even searchable documents. They're scanned images, they're pictures. How do you extract that data out to then consume on the behalf of the individual that's performing some sort of model calculation? So we've worked in areas where we've had semi-structured data, PDFs that are searchable. And we can pull down that information. We've used things from regulatory websites where they're in IXBRL format. They're all structured in a way and consumable that we can ingest them. But those ones that are images, those are really hard. Or those tables that are embedded in a PDF, those are really hard to extract out. And sometimes those tables in a PDF are actually images. They're not even like a Excel-like table that's searchable. So we've been blending different techniques between using the same technology in driverless cars. So optical character recognition, we're looking at ways to pixelate data inside of a box to say that's the number 7 or the letter T. And when I extrapolate that data down, now I've created it from unstructured data to a structured data that I can now store in my local repositories and bring into whatever my models are that I run today. That's the types of calisthenics we're looking to do with our technology, is those labor-intensive activities that humans are doing today, that humans are using their own ability to understand that, hey, where I identify, this label, this document, this, blurb type, I know that means X. And we've been very successful at doing that. Now, that said, sometimes the machines break. And again, this is where me being not a technologist sometimes is very helpful with my peers. I've got a team of data scientists that are out trying to solve these problems. And they stumbled upon one where there was a table that had maybe 6 columns moving left to right. And as they looked at it going vertically down, they recognized that there were some values in columns that didn't have headings. And it just threw their model. There was no heading, but there was a value, and their model couldn't understand what it was doing. And the humans, the data scientists, looked at that and they said, I don't understand what this thing's doing. And then the old operations guy like me that used to have to do these types of things, I said, oh, well, they had something that was split out. They didn't need headers for it. It was just a split out of 2 different values, and they just plunked them there to get that total over here. So there's still roles that the human has to play. And you'll probably hear people talk about like human in the loop. That is something that we firmly believe is critical in these early stages of starting to transition more towards, people use the words AI, artificial intelligence. I like to brand it assisted intelligence. I don't think we're at the stage yet where it's artificial. It's not, having, the HAL 2001 Space Odyssey and taking over. I don't think we're at that stage yet. I think we're years away from that. I think you still need a lot of humans involved in the process so that when the machine generates the output, the human's there to validate it, to reinforce, learn what it's identified. And I think that's a critical function that needs to be expanded. The ability to do the annotations, the ability to understand and override when the machine's wrong. Because these machines can be grossly arrogant with what their outputs are. And you need someone that's really skilled on the inside to understand where it's made some fatal flaws, so you can pivot and change it and make it correct and get into your systems ultimately. Because otherwise, you run the risk of using data that you've collected that you maybe didn't cleanse. You're now ingesting it into something else that you're making decisions off of. And if you don't make sure that that's correct, you can make some really poorly informed decisions.
No, absolutely. Well said. And I love the way you called out assisted intelligence and also human in the loop. I think, which leads into my next segue. You cannot talk about AI without, clearing some of these uncertainties, whether it's machines taking over roles or the time it takes to develop these systems, and, just a general misunderstanding about how these systems operate. There continues to be a, deal of hesitancy towards adoption. So can you tell us some, the biggest AI myths you wish more people understood?
Yeah, people often think when you do this, it's going to be 100%. And when business partners come to you with a problem statement, they expect it's 100% accurate in return. And that's a fallacy. That's never going to happen. That level of perfection is just unattainable, in my opinion. What I try to caution my business partners with is that how accurate do you think you are today? And let's go back and reanalyze the work that you've been doing to understand how proficient are you at being 100%. And then I'll make a deal with you. For every percentage point you're below 100, I'll go 1 percentage point higher. And if that 1% incremental benefit is good for you, then we can move forward. And I try to look at it as how good are you today? And then how good can I potentially make you tomorrow? So I got a bet with a business partner internally, and they thought they were going to be nearly 100%. And they were just sub of 70% accurate with their data curation. And that's just transcribing data from a table to a spreadsheet. And when I showed them that our first pass model was at 91% without any retraining at all, I said, I'm 21% better than you without even reinforced training, where your people have been doing this for a decade. And that's what, sometimes people get very comfortable in their muscle memory. I know what this means, their own personal assumption, or maybe they just had a bad day, or maybe they were trained incorrectly. Or maybe they started to do it in a different way, never documented it, and as it changes hands, humans aren't really great at cascading back, how things are to be done. We're really good at tricking ourselves into saying like, no, this is how I always do it, and even though it may not be, machines will do exactly what you told it to, nothing more, nothing less. And you have always the ability to go back and reanalyze what it did, how it did it, and how it concluded. Sans a black box environment, but you really have the ability to go back in and cleanse this, and you have the ability to monitor it, continuously monitor it, and make adjustments as you learn the outputs and the costs and effects of how it's affecting our business. That to me is really powerful, that kind of constant ability to reevaluate and not be offended that somebody tells you were doing it wrong. The machine doesn't get offended when you tell it was doing it wrong. You just make the updates and move forward. That's what I think. People really need to understand that these things aren't perfect. Neither are we. These machines were designed by humans, so that inherent bias or that imperfection is inherently there in that model. But these things can significantly impact how you do your work. It insulates you from key personnel risk. A lot of people do things manually today. There's that one person in the office that knows how it's done. That person leaves, and now you don't know what to do next. These machines allow you to mitigate some of that key personnel risk, and allows you to really monitor what you're doing, how you're doing it, the time it takes you to do it, how many errors you may be making, and then make better informed decisions. Because a lot of things that are being done manually on people's desktops, you can't analyze that information. It's too disparate. It's too different from one another that you can't harmonize and normalize that data to do any sort of metrics against it. Doing it through these machine learning models, leveraging different domains of AI can significantly help you how you manage your business into the future. And if you don't do it, you are not going to remain competitive, because every startup that's in your business sector, they're using these tools right now. They are chasing you. They have nothing to risk. You have everything to risk in your mature business model. So it's easy for them to chase past you. And unless you start to bifurcate how you do business, managing what you have today and insulating it and making sure it's secure, but also chasing what the next thing is and using this type of technology to get there. If you can't do both, you're going to get passed by the competition.
That's so true. With so many, disruptors coming into the market with nothing to lose, and you're trying to play catch up, and you be in it and insulate yourselves well, as you rightly said. So I've been speaking with Brian Coogan, innovation leader at Fidelity Investments. Look for part 2 of the series right here on CDO Magazine, where we'll continue this discussion on accelerating innovation and digital transformation. Thank you, Brian.
Thanks.